Good morning everyone, how's it going today? Welcome back to the channel and welcome to this new video. In today's video I want to show you how to chat with a PDF and take into account the images, the tables, the plots and everything else that can be in your document for the generation of the response, okay? And we're going to be doing that. That's going to be looking something like this. So in essence, you're going to be querying your pipeline. So here I have an example with the attention is all you need paper from Google. And I queried it. What do the authors mean by attention? Okay. And as you can see that the retrieved part of the document was this part right here, attention. And you can see that we also have the images that were retrieved. And this is everything that is going to be sent to the language model, including the images, so that the language model can give us a response based on this, okay? So yeah, everything in here is going to go into the language model as a context and is going to give us an answer. And in order to do this, we're going to be explaining the whole process with this very nice diagram that you see right here. We're going to be using Unstructured for parsing our document into images, tables, and text. And we're of course going to be using a language model that has multimodal input, okay? That is to say a language model with vision. In this case, we're going to be using GPT-4o Mini in order to interpret the images, the tables, and the text. And as you can see, we're going to be creating this very sophisticated multi-vector store using LangChain. Very cool, very convenient, and it's actually easier than you may think. So we're going to be going through the entire process of this notebook, and the notebook, of course, is available in the description. And if you have any questions, don't hesitate to ask me. And if you don't understand what RAG is, because you probably want to know how to do RAG or Retrieval-Augmented Generation without the images, only with text, you should probably watch that video first. And that is also in the description of this video. And then take a look at multimodal RAG, okay? So there you go. Without any further ado, let's get right into the video. All right, so let's explain a little bit about what we're going to be, what method we're going to be introducing right here. As I mentioned before, this is not the only method, and I am only going to be explaining to you in this particular video the process. We're going to be covering the code for how to do this in the next lesson. For now, let's just cover the process that's the one that that's going to be going on in this pipeline. And the process is actually very well represented in this diagram right here. We're going to be using this library right here that you can see right here. It is Unstructured. Unstructured is an open source library that allows you to extract structured data from your unstructured documents. In other words, it allows you to take your unstructured and semi-structured data that can be coming from PDF files, HTML files like your websites. It can come from a CSV file, for example, from an Excel file. Basically pretty much any any format of a file that you can think of, as long as it is unstructured or semi-structured, and it will split it into different components. So you will have your PDF document, you will pass through the unstructured library that we're going to be using, and we're going to get one array with all of the images from your entire document, another array with all of your tables from your entire document, and another array with all of the text of your entire document. And this is going to be very convenient because this will allow us to treat those types of elements differently and to embed them and to load them to our database differently depending on what they actually are and what they need to be loaded and what transformation we need to do in order to use them in our RAG pipeline, okay? So that's the first step, the extraction. Once you have extracted this, that is probably the most difficult thing to do and the most magical one, because Unstructured is just so amazing for this. we're going to be loading this to, we're going to be using a language model in order to summarize them, okay? So we're going to attach a summary to every single element that we have right here. What I did in this particular example is I used a regular language model for the tables and the text. So I converted, of course, the text and the tables are regular text representation. Actually, Unstructured allows you to extract the HTML representation of a table that is within your PDF. So you will send, what we're going to be doing is we're going to be sending the HTML representation of all of our tables to a very quick language model. In this case, I'm going to be using language models from Grok. I think I was using Llama 3.1, and create a summary for the table. And then we're going to do the same thing for every long piece of text. We're going to be creating a summary for that piece of text that is going to allow us to embed the summary instead of embedding the entire text. This is going to help us with retrieval. Usually that's a good technique because it allows you to focus on the keywords that are actually relevant to the text that you're going to be embedding. And for the image, we're going to do the same thing. We're going to also summarize, or more than summarize, describe the image that we're going to be covering. And in order to do that, we're going to use a language model that has multimodal capabilities. In the case of this example, I was using GPT-4o Mini, okay? But feel free to use any language model that has multimodal input. You can use, for example, Gemini 1.5 from Google. You can use Lava, for example, if you want an open source model. But yeah, just to be clear, up until this part right here, we have already extracted all of the images, all of the tables, all of the texts, and we have also tagged them with a summary. And it is the summary, the one that we're going to embed using the embeddings model, okay? So that is the next step. Once you have extracted every single thing, we're going to tie them together, the summary and the original element, using a doc ID. Okay, this is going to be just a string with a Unicode, not a Unicode, but a very specific ID that is going to link the original document to its summary. Okay, so we're going to have all of our summaries linked. We're going to create documents from the summaries, and in the metadata of each one of our documents, we're going to put the ID. And the same thing, we're going to create an element right here, and we're going to tag them. The metadata of each one of these elements is going to have the same doc ID as their summary. And then these summaries are the ones that are going to go into our vector store. And this right here is pretty much the same thing that we have been doing so far. We're going to be vectorizing them using a text embeddings model. Then we're going to load it into a vector database. In this case, if I remember correctly, I was using ChromaDB. And the documents, actually, they're not going to go into the vector store because we're not going to be embedding them. As I told you before, that could be a possibility, and that is actually one way of doing this. If you want, you could embed the whole thing using a multimodal embeddings model. But in our case, we're not using a multimodal embeddings model. We're only using a text embeddings model, and we're only going to vectorize the summaries, okay? So we're going to put the summaries into a vector database, and the documents, we're going to load them to a different database. We're going to call it our document store, okay? But remember that even if they are in two different databases, they are still linked by this doc ID metadata that we have assigned to them, okay? And this is very relevant because now a retrieval becomes much more, becomes possible, because now you can query your vector database like you would query a regular RAG pipeline, and then the vector database will return to you the most relevant documents for your query. So for example, let's say that you're embedding, let's say that you're loading a document. For example, you're loading the document, the research paper, attention is all you need from Google, right? And you're querying something like, what is multi-head attention? So you're going to get that is going to retrieve the summaries of the documents that talk about multi-head attention, Okay, so that's the retrieved documents. But in this case, remember that our vector database only contains the summaries, not the documents themselves. And that is very important because we have the doc ID metadata assigned to them. And this doc ID is the one that we're going to use to fetch from the vector store the documents that are actually, that we're actually looking for. So then we're going to fetch those documents. And since those documents, remember that could be images, tables, and text, we could actually get from the retrieved documents not only text, but also images, tables, and texts. So that is essentially what we're going to be doing and how multimodal retrieval works in this particular way of doing this. So we have our, so just by the end, as you can see, we have a very simple retrieval pipeline in which we just ask a question, send a query in text, and as a return, we get documents that can be images, tables, whatever we want, whatever we loaded to our vector store, and whatever we were able to tag with a summary, okay? And then we use that to generate an answer. If we get images as context, then we're probably going to have to use a language model that has multimodal input capabilities if we want to use the images as context, which I suppose that is what we want to do. So yeah, that is the whole process that we're going to be building. In the next lesson, we're going to be showing the code about how all of this works. All right, so let's actually start with the code right now. And the first thing that I want you to do is to install the packages that we're going to need in order to run the dependencies, okay? So it depends on what OS you're running, but you're going to need Poplar, Tesseract, and libmagic. Here are just the quick instructions to do this, to install them for Mac or Linux. If you were using Windows, there's also like the instructions to build this. I'm probably going to post them under this video. But yeah, just to get that installed. I already have it installed, but you can do that. The next thing to do is to install the dependencies that we're going to need. And the ones that we're going to need in this case is Unstructured. Oh, by the way, this notebook is of course available. Like in this lesson, you can go right under this video. There is the link to open it. And yeah, you'll have access to the entire thing, the entire code that is right here, so that you can run it on your end and implement it to your own pipeline. So as I was telling you, we are going to be installing Unstructured. We're going to be installing Pillow, LXML. I installed Pillow twice because why not? In my case, I'm going to be using ChromaDB. We're going to need to have TickToken installed for the tokenization. We're going to be using LangChain. We're going to be using LangChain Community, LangChain OpenAI, because I'm going to be using as my vision model, where I'm going to be using GPT-4o mini, if I remember correctly. And for the just text-based language models, I'm going to be using Llama 3, if I'm not mistaken. And just python.env for my library, for my environment variables. And if you have any questions about it, so I'm going to be, of course, initializing a Grok API key to use my open source LLM models from the Grok API, the OpenAI API key, of course, which you can get from the platform dashboard. And then I also initialized a LangChain API tracing and the LangChain API key, which are the API keys that we're going to use for Langsmith, because I want to be able to trace what's going on behind the scenes in this pipeline. And once that is run, I'm actually going to run it like this. I'm actually going to restart the kernel because I realized that the whole thing, I had already run it, so I'm on run 101 right now. So just to make sure that we're all working with a similar environment, now I'm going to rerun the whole thing. So once you have installed everything, the first thing that we're going to do is we're going to partition our PDF, okay? Now, in our case, we're going to be dealing with the attention is all you need PDF, which we have right here. And this is just an example, of course. Feel free to use any PDF you want. But I figured that this was a good example because even if it's a bit short, it's just 15 pages. It has some images, it has a lot of text, it has some equations as well, if I remember correctly. And yeah, I mean, it's just a multimodal document that is actually like more similar to the PDFs that you would see in real life. Here we have a table as well. We're going to see how unstructured and how our pipeline extracts it. But this is the file that we're going to be loading. So the first thing that we're going to do is we're going to partition it. And in order to partition it, we're going to be using unstructured. Okay, so let's get into how we're going to be using unstructured and what each parameter right here does. And before I forget to mention this, this video is actually a lesson from the AI engineering cohort that I host, where I teach you how to go from beginner to this level of creating multimodal RAG applications, and from this level also all the way to creating multi-agent systems, okay? And this is a program that not only includes pre-recorded material with all of the content, but also includes my personal help. If you get stuck or something, I can be there to solve your questions. There are live sessions. It is a cohort course, which means that you will be interacting with me live. So be sure to join that if you're interested in that and joining the community. It is pretty fun, and I can't wait to meet you there if you're interested. Just let me know if you have any questions about that too, okay? So on with the video. Okay, so what do I have right here? I have this this function right here. I mean, I'm calling this method from unstructured. Remember that we have already installed unstructured, and I actually installed support for all kinds of documents. In this case, I'm only going to be using PDF, so I could have technically just installed the PDF packages. But I mean, if you're going to want to install all docs if you're going to be parsing a lot of different formats. And in this case, I'm going to be using the partition PDF method from unstructured. Now, something that it might be important to mention is that right here, I am not using the loader from LangChain, okay? LangChain actually has a loader for unstructured, and it works pretty well. You can use it both locally and also with the serverless API. But I wanted to show you a little bit more of the flexibility that you have with unstructured, so that we can see actually how all of these parameters work with the unstructured API, so that you can actually feel and see what's actually going on under the hood when you're using unstructured. So the partition PDF method, and pretty much any partitioning method from unstructured, basically takes the file path to the file that you want to partition, and it returns the partitioned elements, okay? That's the only mandatory parameter that you're going to pass, but here are other arguments that are available, and let's take a look at them, okay? So first of all, we have the strategy, which can be high res or it can be normal. And in this case, we're going to be choosing high res because we're setting this this parameter to true, infer table structure. And this parameter essentially just means if you want to extract tables from your document or not. And if you want to extract tables from your document, you're going to have to set it to true. And if you want to extract tables, then the high resolution strategy is mandatory. You're going to have to choose this one if you want to extract tables, okay? So that's the first thing. And in our case, we are going to want to extract tables, so we're going to choose these settings right here. Now, something else is that you're going to want to choose the kind of images that you want to extract, okay? So in this case, I have actually, I don't have it here, so that's good. I have this right here, and in this particular case, what I have seen in previous examples of this tutorial, because I am basing this on a cookbook from LangChain, is they were using this parameter right here, which is extract images in PDF, and I set it to true. However, that parameter is actually deprecated or on the way of being deprecated, so you don't need to add it anymore. I just added it here for context because you're probably going to find it in the wild or in other tutorials if you don't, if you're, so you don't get confused about it. So the new way of doing this, the updated way of doing this is with this parameter right here, which is extract image block types. And right here, you're going to set it to image if you want to extract the images from your PDF. If you want to extract the tables too, for example, you're going to tap table to like this. Now, in our case, we only want to extract the images. This is not necessarily not going to extract the tables. It's just not going to extract the tables as images, okay? It's still going to extract the tables, as I'm going to show you in a minute. And if you want to extract the images to an actual folder, to an actual directory in your computer, you can enable this, and you can pass in an output path to save the images to, okay? That's also a possibility. In my case, I'm not going to enable it. Just going to set it like this because I don't want to have the images from my PDF downloaded to my computer. Just want to have them in the partitioned element. But feel free to enable this and play around with it, and you will see that this will create a new folder right here with all your images, okay? Next thing that we have right here is extract image block to payload. And this essentially means that we are going to be extracting the images, and the image is going to be have a metadata element that is going to contain the base 64 object of the image, okay? So if you set this to false, you're not going to be extracting the base 64 representation of your image, which would be terrible because you're going to need the base 64 representation of your images if you want to send them to your language model. Because if you want to send an image to your language model, you're going to have to send it to the API using a base 64 representation. So this is the way to do it. Then this part right here is actually very interesting. And actually I'm going to show you how this works without it first. Because it's super powerful and super cool. But let me just show you how this works without it. So without it, I'm going to run this. And it's going to start running. It's probably going to take a few seconds. But what is going to happen right now is that it is going to extract every single element from my PDF. So it's going to return the table. It's going to return this paragraph, this other paragraph, this title right here, this other table. And it's going to return everything just at once. All the elements of my entire document are going to be returned into a single array. And that's okay. That could be what you want to do. But the unstructured service actually allows you to do something super cool, which is to chunk it to similar, to chunk it by a strategy that you can choose, okay? You have by title or basic. And this essentially means chunking. Usually you might be used to thinking of it, but that it means making things smaller. But actually in this case, in their case, when you implement a chunking strategy in Unstructured, it means you're putting elements together. So right now, without the chunking strategy, we're going to see that if we see what kind of documents were returned to us, you can see that we have title documents, we have narrative documents, we have footer documents, image documents, etc. So all of this are actually the ones that are available to us, okay? This one's right here. And that's great. That's great. We have all the documents in a single array, but you probably don't want that. Actually, let me just show you what this looks like. So if I do length of chunks, you're gonna see that we have 218 different elements inside the document. So it split the entire PDF document into 218 different elements. So we have, this one might be one, this one might be another one, this title might be another one, the table might be another one. So you don't really want that. what you want is to have them together, to have the elements together that are related to each other. And that's where the chunking strategy comes into play. I will let you play around with this to see what it actually does. But if we enable chunking, going to rerun this, but with chunking this time, I'm going to set the chunking strategy to by title, a maximum size of the chunk to 10,000 characters. We're going to combine text characters. We're going to combine different elements when they are under 2,000 characters. And we're going to start a new part of the document after 6,000 characters. You can take a look at the documentation if you want to delve into this a little bit more deeply. But what this is essentially doing is that it is taking the elements from the 218 elements that we have in the document. It's putting together those that are related inside the document. And if you choose by title, then it's probably going to go right here to our document. And it's going to be like, okay, so this is one title. So all of the documents inside this title are going to be assigned to a single chunk. That's how they call it. And then all of the elements assigned to this other title are going to be under a single chunk as well. And this is actually super useful for RAG, because if you're dealing with a document like this one, you're going to have a titled chapter talk about one single topic, one single, it's going to have cohesive meaning. And that's going to be super useful for RAG. So you're going to be able to embed an entire chunk that is related. It's basically extracting chapter by chapter of the document. So that's pretty useful. It actually finished exporting it. And you will see that in this case, we don't have 218 documents anymore. We only have 17. And in the same way, we don't have all of the different types. We only have these two types, which is composite element and table, okay? And composite element, actually, let me just show you what it looks like. I'm going to go right here. Going to go right here and let's see. So from chunks, I'm going to see the first one. Let's see. So the first one is a composite element. I'm going to say to dictionary. And you can see right here the elements of this composite element. You can see that it's type of composite. It has an ID, it has some text, it has some metadata, it says which page number it comes from, etc., which is very cool. But interestingly, it has this property inside of its metadata. And that property right there, let me show you. Metadata. And I'm going to use this property right here, which is original documents. And that one right there, show you, not like that, like that. That one right there actually contains all of the documents that are related or associated to this particular chunk, okay? So remember that we have 218 documents or elements inside the entire PDF. So for 15 pages, Unstructured extracted 215 or 17 elements. And then it associated them together using a by title chunking strategy. And the 17 chunks that it returned to us are actually sets of these components right here. And since we used the by title technique, these are supposed to be one after another under the same section of the PDF. I'm going to show you how this looks like in the actual PDF in just a moment, but just, start visualizing it. I'm actually just going to show you right now, like how it looks. Where do we have this? I think it is here. I was just running some tests. But here, as you can see, here is one chunk. I'm going to be displaying one chunk. And as you can see, this chunk right here has, it starts at this title called attention, and it goes all the way up to here. So as you can see, it is kind of a chapter in the document, and it contains 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 elements inside of this chunk, and they are all associated to the same title. That is because we used the chunking strategy, okay? And that is also the reason why we only have composite element and tables that were extracted, okay? Because the composite elements are the ones that contain all of the other elements inside of their metadata, and they under the key of original documents, okay? So far, so good. We have successfully extracted our documents. I'm going to erase this one because I had already shown it to you right here. But as you can see, inside of the metadata, original elements key, we have a title, narrative text, a footer, a couple of images. For this one in particular, we have images, the title, etc. Okay. And let me show you how the images look like inside of an unstructured document. So in this cell right here, what I'm doing is essentially just extracting only the chunks. Only the elements that have and that are of type image. Okay. So in here, I basically listed all of the elements in chunk 3. Here we have a title, a narrative, etc. So what I'm doing right here is I'm just extracting those elements that have images. So I'm taking all of the elements from the chunk 3, and then I am extracting the images from that chunk, and I'm just selecting the first one and converting it to a dictionary. And here you can see the representation of an image that was extracted by Unstructured. So you can see that it has a type of image, it has some text because it is able to extract the text within the image. It has the coordinates within the document itself. This is going to be very useful afterwards if you want to highlight where in the document this particular element is located. And then very importantly right here, we have the image base 64 representation. And as you can see, it's super long, but that's exactly what we want. And we are only getting this because, remember, we set this parameter to true. Extract image block to payload to true. And that is the only reason why we are getting this key right here, okay? And it is, of course, very important because this is the one that we're going to be sending to our multimodal language model, okay? So far so good. We have successfully extracted the elements, and we can actually now split them. So by the end of this splitting technique, we're going to essentially have 3 different arrays, one of tables, one of texts, and one of images, just like we had in the diagram that we showed before. So for chunk in chunks, for the 17 chunks that we extracted, we're going to append the element into table if it's a table, and we're going to append it to texts if it's part of the composite element. Now this is technically a shortcut because remember that inside composite element there is also images, but we're going to treat the images differently. Of course, you can improve on this pipeline if you want and actually parse the images within the composite element as well. You feel free to do that. But in this case, I'm just going to be extracting the images and the composite elements and treating them as these 2 different elements, okay? And then third, I'm going to extract the images. And in order to extract the images, I'm going to extract them from the composite element right here. Going to tap into every single composite element. If within the composite element I have an image element, I'm going to add it to my images array. So that way by the end I have these 3 different arrays, one for tables, one for texts, and one for images. And we have successfully completed the partitioning part or the extraction part. Now what we're going to do is we're going to have to transform it, okay? And here I just have a very quick function that displays any image in base 64. So here, just a very quick function made with ChatGPT, but essentially just takes the base 64 code of an image and it displays it. And here you can see that one from the array that we created, the first element of the array, I'm going to show it. And as you can see, this is the first image that was extracted from the document. Seems to be working pretty well. So now we have these 3 arrays. Now it is time to actually go to the next part of this, this exercise, which is summarizing the data that we just extracted. So we're going to be creating a summary for each image, for each table, and for each piece of text. All right, so now it is time to start summarizing the data, okay? And that's what I'm going to do right here. In order to summarize it, I'm going to be using, first of all, a model from Grok. I'm going to be using Llama 3.1, if I remember correctly. And in order to do that, I'm going to be installing, of course, Grok. I'm going to be using chat Grok, importing it from here. I import chat from template and my regular string output parser to create a chain, okay? Now, the chain that is going to generate the summaries for my text elements is going to be this one right here. You're an assistant tasked with summarizing the tables, etc. Just a very simple chain. It's going to pass in the prompt, the model, and then the output parser. And as you can see, I'm initializing Llama 3.1 from ChatGrok, okay? So I'm just going to run this right here. I actually think I forgot to execute this one right here. There we go. And now just to show you what texts look like, because remember that we split all of our elements into tables, texts, and images within the retrieved documents. Texts itself, remember that it is a composite element. I mean, it is a collection of composite elements, right? And what does that mean? Remember that I told you that it means that in its metadata, there are the original elements. And that essentially means, I have to tap into the first one just to show you. That essentially means that all of the elements are within original elements like this, okay? But however, you can still print it. Oops. You can still print it like this. And it's going to show you all the elements of that collection of elements, okay, of that chunk. So here I have my scrollable element. And as you can see, here's all the collection of all the text for this first chunk. As you can see, it's just the title and the abstract. That's the first chunk. Now, what we're going to do right now is we're going to use that in order to summarize it, okay? So we're going to pass in every single one of those texts, every single one of those composite elements, and we're going to summarize them. And I'm going to show you what it looks like on Langsmith a little bit later on if you want. But the idea right here is that it is going to take the entire contents of all of the elements within the composite element. It's going to batch execute the summarized chain, and that's going to go to summaries, and the same thing is going to go to the tables. However, let me show you something quick about the tables. So the tables that basically look like this, okay? We have 4 tables in the document, and let me show you what it looks like. So to dictionary, and actually, I'm gonna have to click on the first one right here. And you can say this is the first table that we have. We have the element ID, we have some text within it, and then it has this very convenient feature, very convenient property, which is text as HTML. And that essentially means that it is the extracted table, but in HTML format. And this is the only thing that we actually need to send to our language model in order to summarize it, right? We don't really need its original elements, because if we try to tap into the original elements, for example, let's see, metadata, original elements, let's see what that looks like, to dictionary, Does that look like anything? No, there's not a dictionary here. It's a table apparently. I don't know why I have a base 64 thing right here. But yeah, I mean, what I wanted to show you is that we have the HTML code inside of here, and this is the one that we're going to send to our language model in order to actually get the summary. Because remember, I mean, if you have a language model, you have to send it text. You cannot send it just, or an image if it's a multimodal, but you cannot send it just the text like this. It's probably not going to understand the divisions. There is no headings or anything right here. You want to send it the actual markdown, the actual markup language, so that it can understand where is the header, what is the table cell, etc. So these are the ones that we're going to be tapping into, and that's what's actually going on right here. So I say that the tables HTML is actually going to be the property text as HTML of each table in the array tables. And then I batch that too. Let me just execute this. Take a few seconds, and let me just show you what it looks like. I have it right here. So that's for the text summaries. So as you can see, we have 1, 2, 3, a bunch of text summaries, like about of composite elements. All of these are the composite elements. And here you have every single summary. And then we're going to do, let's check the same thing for the tables. Table summaries. Table summaries. And here we have 4 tables. The table compares 4 types of neural network layers: self-attention, concurrent, etc. And as you can see, these are the summaries that I am going to be vectorizing and embedding and adding to my vector database. And now let's do the same thing for our images. And in order to do that, we're going to be using OpenAI, of course. So first thing to do is to install it. There we go. And similarly to the previous examples, we're going to be also creating a chain that is going to summarize the image. But in this case, we're not going to be sending a regular prompt like we did before, but we're going to be loading the message with the image itself. And if you have, I mean, if you can check the API documentation of whichever LLM you're using to see how you can send an image to it. In LangChain, it is pretty uniform. You just send a user message, and you send whatever you want to send it as text within the type text dictionary, and then you create another dictionary within it with type image URL, and then you send it in base 64 in order so that it understands that image. And that's essentially how we're going to be sending that image. So as you can see here, we have a prompt template that is going to take only one variable, which is image. And here we have another template that is not taking any variables, so that's convenient. And then right here, this part right here is going to be the base 64 code of the image that we want to convert. And in order to do that, we just like initialize our chain. In this case, we're going to be using GPT-4o Mini because we want a language model that has multimodal input, okay? And then just batch the summaries. Let's execute that. That actually takes a little bit of time when it is trying to ingest all of those images. As you can see, I think we have 1, 2, 3, 4, 5, 6, 7 images right here. So let's see how long it takes. It took 16 seconds to process all those 16 images. Now let's see the summaries. Here we have all the summaries. Let's print the fourth one. There you have it. The image appears to illustrate the attention mechanism used in transformer architecture. Then we have the key elements, words and tokens, attention weights, highlighted tokens, etc. Let's actually take a look at that one to see what it actually looks like. So what was the name of the function that I had up here that displayed the image? Display base 64 image. So let's use it right here, and let's print images number 3. Here we have the image number 3. Let's check the number 1. in the strategy concept of the transformer architecture, trying to find an easier one to visualize. Let's see, which one was this one? It was image 0. So image 0 is, of course, still this one that we saw before. And if we check the summary of that one, we can see that the overall structure is a diagram structured into 2 main sections. We have the encoder and the decoder, then some arrows and connections. Okay, so this is exactly what we want to embed. Okay, these are the summaries that we're going to be vectorizing and adding to our vector database. I'm going to remove these 2 examples right here just to make it easier. But there we go. So that was creating the summaries of all of our elements. And as you can see, we already have the 3 arrays with the images, the text, and the tables. And then we have other 3 arrays with the corresponding summaries for the text, the summaries for the tables, and the summaries for the images. Now what we're going to have to do, as we saw in the diagram that we saw before, we're going to have to link them together using an ID. And that's what we're going to be doing right now. And then we're going to be loading them to our vector database and to our document store. Okay, so now it's actually time to start talking about how to load those summaries and the elements that we want to load into our vector store and to our document store. And in order to do this, it's actually very simple. We're going to be using this LangChain abstraction called the multi-vector retriever. It's actually pretty straightforward. And what we're going to be doing with this one is what we saw before. We're going to be creating an ID for every single document, and we're going to add it as metadata to both our summary and to our document. And the document is going to go to the vector store, which is right here, and the document is going to go to the document store, which is right here, and the summary is going to go to the vector store. And it is the summary which we are going to retrieve using semantic search, semantic similarity. And once we have retrieved the summary, we're going to check the ID of the document that it's in its metadata and go fetch the corresponding document in the document store that has the same ID. Okay, and that's essentially all that we're doing. And this is what the multi-vector retriever does in LangChain. Now, of course, you can code this yourself if you want. You're not forced to use multi-vector retriever. I just feel like this is a good level of abstraction to start to stop at, because I feel like what's going on under the hood is pretty self-explanatory, and this one right here does it very, very simply. So you just pass it the vector store, you pass it the document store, and you pass it the ID that it's going to add to the metadata. I mean, the key that it's going to add to the metadata to connect both of them. That's essentially all that we're doing. So we're initializing a chroma vector store. We're initializing then a document store in memory in this case, and we're initializing a metadata ID, which is going to be document ID, like this one right here. And then we're just loading everything into, just creating this abstraction that is going to help us link them together. And this retriever is actually going to just return to us the documents that are going to be relevant for this. It's not even going to return to us the summaries. It's only going to return us to documents. So let's execute this right here. Now we have created this, and now we can actually start loading our documents. Now that we have created it, this is actually empty for now, okay? And now let's actually just load every single thing that we want to load. So the first thing that we want to load is the documents. And just as I showed you before, we have to create some IDs for each one of them. The first thing that we're going to load is the texts, which are the composite elements. And as I told you before, well, first we're going to have to create an ID for each one of them. So this array right here is going to create a UUID for every single element in texts. And then we're going to append that ID. We're going to add that ID to the metadata of every single document that we're going to be generating. So this essentially is just a one-liner that creates a document a LangChain document for every single composite element that was returned to us from Unstructured, which is in the text variable. Okay, so this is creating the summary texts documents. Then we're loading those documents to our vector store, and then the actual text, the actual composite element, the composite element that we extracted from Unstructured is going to go to the document store. And this one is the one that is going to be retrieved, not the summary. The summary is only used for finding it, but the one that we're going to actually get from the retriever is this one right here, okay? We're going to do exactly the same thing with tables. We're creating a LangChain document. In case you don't remember, I imported document from here, from langchain.schema. Actually, I think this is wrong. That is old school. I think now it's from LangChain core documents. We import document, yeah. Wow, this is old code. All right, let me just fix this. From LangChain OpenAI, we're going to import OpenAI embeddings. Yeah, I don't know what this is. Old code. From LangChain core.retrievers, we're going to import multi-vector retriever. There we go. Is this working correctly? Multi-vector retriever. Actually, I think this is, yeah, sorry. This is the only one that actually comes from LangChain retrieval multi-vector. So there we go. And then we're going to add every single thing. We're going to be doing exactly the same thing for the images, just generating an ID for every single image, creating a document for every single summary, and then just adding the images themselves to the document store. And it is the image itself in base 64, which is going to be retrieved, okay? So it's going to take a few seconds to load everything. And now we have everything within our retriever, our document store, which has a vector store assigned to it. And now we can actually start testing it. So now if I do what is multi-head attention on this retriever that I have right here, remember that my retriever is a multi-vector retriever, okay? So now I can essentially just execute this. And now the chunks are going to be right here. Actually, let's just see. There we go. So the first chunk is a composite element. The second chunk is actually a base 64 thing, which has to be an image because that is what we added to our document store. Here we have another composite element and another composite element. So pretty convenient. Now, right here, this is some extra code. You don't necessarily need it. This is high code, some code that actually was available at one of LangChain's documentation pages. I'll add a link to that one in the description. Essentially just renders the page and highlights whatever elements you send to it. I just had to update that a little bit. But let me show you. I'm just going to create the function and let me show you what each one of those chunks that we just retrieved has inside of it, okay? So these are our 4 chunks, okay? And remember that for the composite elements, they actually have some more elements within it, okay? So this first one, we're going to tap into this first one, is a composite element. Remember that it has a lot of things within it. And let's actually just take a look at what it has inside of it. So for every single composite element, we're going to check. First, we're going to print the number of it. And then we're going to just write down what type of element it is and which page it is on, okay, just to see. So you can see that the first chunk that it retrieved has a title, narrative text, and all the way to a list item. And you can see that it spans from page 4 to page 5. Pretty good. Here we have the chunk number 2. Let me just run this as scrollable object. Here we have chunk number 2. You can see it has a title, a narrative text, a footer, all the way to a narrative text, and it actually spans from page 2 all the way to page 4. Pretty good. Same for chunk 3. All right, pretty good. Now, let's actually take a look at the first chunk right here. I think I forgot to do something right here. Chunks.metadata. Oh yeah, because this one right here is actually the image. Let's open the first one. All right, so the first chunk and the first original element from the chunk is a title, just like we saw before, and it's in page number 4. There we go. Okay. And actually right here, I just coded a couple of quick functions. I don't want to confuse you with these functions. Essentially, all they do is they extract which pages a given chunk has, because remember that a chunk in itself contains a bunch of elements, right? So the first one contains, as we saw right here, the first one contains the title from page 4 all the way to a list item in page 5. The chunk number 2 contains all the way from the title in page number 3 to a narrative text in page number 4. And here I just coded a very quick 2 functions that actually display the picture, the pages of whichever chunks you pass to it. So here I'm going to pass the chunk number, the first chunk. And wait, what? This one was actually not useful. All right, so there we go. The fourth chunk contains an introduction, background, etc. Okay, so it's only one page, this one right here. Let's see. Let's check the chunk number 2. It is supposed to span from page number 3 all the way to page number 4. So let's check that one right here. So which one was it? Chunk number 2. So let's see that one. Chunk number 2. So it spans from here, from attention, all the way to page number 4. And these are the elements that were retrieved. So as you can see, this chunk in itself is pretty self-contained, and it contains all of the information that we need that is related to this particular topic. And that is why it is so useful and so important to use chunking by title in this kind of documents when you're using Unstructured. It becomes super easy because everything, the entire chunk is interconnected. It's not like it split the text randomly and it stopped chunking here and then in the next text, the next chunk starts here. It literally is by title, which is very, very convenient. And it actually has the images here. Now in this particular example, I am not extracting the images from the chunks themselves because, as you may have noticed so far, I am embedding the images separately, but you could just extract the images from here and that would work pretty well. So now that we have that, we can actually start creating the RAG pipeline, which we have all the elements so far. We have the retriever that is working. The retriever is multimodal. Actually, let me show you that it is actually multimodal. Where was the function right here that we had that could display images? This one right here. So this query retrieved 4 documents, and as you can see, the second document is a base 64 document. So let's take a look at it. So we're going to check chunks, and we're going to check the second one right here. This is going to tap into this element right here. Okay, so let's execute. So there we go. We have retrieved the image. We have retrieved all of the documents themselves. And now we can essentially start creating our RAG pipeline. So let's actually get to do that. Great, so now in order to create our RAG pipeline, essentially all that we're doing here is we're actually going to be using a couple of helper functions. First of all, we're going to be importing the runnable pass-through and the runnable lambda things we're going to be using. And remember that this chain right here is supposed to actually give you an answer based on the retrieved documents, okay? And that essentially means that since the documents that will be retrieved, some of them will be images, the chain has to include a language model that has multimodal input, which is the case with GPT-4o mini right here. And that's the model that I am using for this one right here, okay? So I created a couple of chains right here. The first one is this simpler one, and probably the one that you would intuitively create. And the idea right here is essentially just a very regular RAG pipeline, like the ones that we have built before. Okay, so the entire chain actually takes just a single input, which is going to be the query from the user. And in this case, that query is going to be passed through, the runnable pass-through as a question. And for the context, we're going to be using the retriever. However, the retriever, we're going to be parsing it using this function parse docs, okay? And as you can see right here, we have a runnable lambda. And a runnable lambda is essentially just the same thing as creating a lambda function. And let me show you what that one does. So essentially, it just splits our retrieved documents to know whether or not they're whether or not they are an image. Okay, so it essentially tries to decode it if it was base 64, and if it cannot do it, that means that it is not an image and that it is text. So it appends that to my text array, and it returns images and texts. Okay, basically this function right here. So this one right here will return just the retrieved documents like this, okay? So that is what the retriever is going to return. And an object like this is going to be passed to my parse documents function, and that parse documents function is going to try to decode every single element in this array. And if it can decode it, it's going to add that to the images array. And if it cannot decode it, it's going to be added to the texts array. And the texts are going to be added, texts, within the text one, we're going to have the tables and the text, okay? Those texts are going to be right here. And the images are going to be right here. And this is the dictionary that is going to be returned. And that is pretty important because our prompt is going to take these two keywords right here, which is the ones that are going to be sent to this other runnable lambda that we have right here, okay? So by the end of this thing right here, this one right here is going to get a dictionary with the keys context and question, and within the context key, the value is going to be another dictionary with these two keys, okay? So far so good. There we go. And this function right here is going to take whatever is within the context and send it to this new prompt that is creating, okay? So very simple. Here we have the context text, and essentially we're just appending more context text if the context from our retriever, the element in the context from our retriever is of type texts, okay? So we're tapping into the documents by type right here. And so we're just appending those right here. And if it is not text, if it is image, we're going to be appending this part right here to the message, because remember that if you want to send an image to a language model, you're going to be adding it like this, okay? So other than the message, which we have right here of type text, we're going to have the image type image URL and then appending the base 64 image right here. And then just creating a human message with this prompt content that we have right here, okay? That's all we're doing. And if there are no images, then this is going to be ignored, and we're just going to be appending the composite elements inside of the prompt, and that's all that we're going to be doing, okay? So far so good? Perfect. This can of course be improved. I feel like I'm not dealing with the tables correctly, perfectly. I feel like I could structure this better to deal with the tables a little bit more neatly. But this is just a very quick example to show you how this would work. So this is what the chain would look like. After that, we just pass everything to the language model and just string output parse it. That's all. And then right here, just have a very, very quick example of doing exactly the same thing but with retrieving the sources. So we're creating a runnable pass-through that is going to create, remember that if you run assign on a runnable pass-through, this is all, of course, by the way, in the LangChain module that we have in the previous part of the course, okay? So if you're having trouble with the runnable pass-through, there is a video about that in the previous module that we talked, where we had, where we're covering LangChain. And it essentially, this thing right here is going to return a 3-key dictionary: context, question, and response. And the response is, of course, going to be returned, the response from the language model. So here we have the first example, which is chain invoke. What do the authors mean by attention? And then it gives us the answer. But we don't really see what's going on right here. So actually, let me just execute this. So there we go. It's going to take a little bit of time because it is retrieving the images, and if it finds images, it's going to retrieve them. The authors define attention as a mechanism that maps a query instead of key value pairs, etc. Okay, so here we have the answer. In the next part right here, we're going to be checking the Langsmith logs of these 2 queries, but just to show you what's going on right here. And let's try this other one, which is essentially, actually, let's try the same exact question. There we go. We're going to try the same exact question, but this time we're going to execute it with the chain with sources. And this one essentially is going to return a 3-key dictionary with response, context, and question. So what I did right here is I basically just printed the response. Then I print context. Actually, I'm going to add another empty line, another couple of empty lines right here. And then for each text inside of it, we're going to just print it. And you're going to print the page number as well, because the page number is, if you might remember, inside of the metadata, inside of the page number of the document retrieved, because we built the document using the unstructured composite elements that were returned to us. And then if it is an image, we're going to just display it using this function that we had up there. Okay, so let's execute this. Again, going to take a few seconds, and there we go. So here we have the response. In the context provided, attention refers to mechanism used in neural networks, etc. So working pretty good. And then for the context right here, we have attention, and we have it. So it essentially fetched this part right here. So attention, tuck, 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 and then it fetched a couple of images. So let's see if if it did exactly the same thing, it should have returned this chunk. So let's see. It fetched these 2 images right here. All right, not bad. There we go. And it fetched attention. It actually apparently fetched only 2 text documents, one from page number 3 and the other one from page number 10. And I suppose that it actually fetched this one kind of like by mistake, because I mentioned authors. What did the authors mean by this? And here's just a list of a lot of authors. And then it fetched a couple of images that I'm not sure if it actually helped it answer it, but you can see how this is going to be useful. Like if your document contains a bunch of charts, for example, this is going to be super useful, because in the response, you're going to be able to get the image itself. And this is something that you can display in the front end of your application, right? You don't necessarily need to just cite it with a short reference to the page. You can even display the image because it is being returned to you in base 64, right? And you can even use the image within the answer as well, if you allow the language model to print the base 64 elements that it is returning. So that is very convenient, and I can't wait to see how you build your own workflows for this kind of implementation. And yeah, I mean, essentially this is going to allow you to work with more real life more real life scenarios where you have more realistic PDFs with images, tables, graphs, plots, equations, etc. And it's going to be able to parse them. So this is a rudimentary explanation. I mean, there's of course a lot to go deeper into, but I hope that it was clear. And of course, there are like multiple ways to improve on this particular code that we have right here. But I feel like it'll give you a very good starting point so that you can start experimenting with it and creating your own workflows. All right. So there you go. That was how to create a multimodal RAG pipeline. And I hope that you learned a lot from it. Now let's actually start putting this into action. So the next part that we're going to be doing is going to be implementing this thing right here into a front end. We can use Streamlit for that, right? So let's do that afterwards.